Hello again, class. So this is a problem that we were trying to figure out, and it's asking about how many moles of Fe2O3 can form from using 6 moles of O2. In this equation, they give us the equation. In this equation, actually, you can see that 3 moles of oxygen can form 2 moles of Fe2O3, but we need 6 moles of oxygen. We need to calculate it for 6 moles of oxygen. So what we do is the first thing to do is to actually organize our thoughts. Come on. Okay. So we need a relationship between these two. So given needed 6 mole O2, mole Fe2O3, and you look at the units, moles and moles, then you will be using mole to mole ratio. And then you're using oxygen and product, so you need to move from the oxygen to the product. So here from this equation here, you can say that 3 moles of oxygen form 2 moles of Fe2O3. And then you can have 2 conversion factors, like so, or like so. And then we are ready to set up our equation, which has to start with 6 mole. This is my favorite color. So 6 mole O2 times conversion factor, and then the needed is mole Fe2O3. So here we need to get rid of the oxygen, so the best one to use is actually this one here. So 2 moles Fe2O3, 3 moles O2, and then red to cancel out this, and you can get the result. It will be, and you check first the unit. Is this the last thing you need from the needed? Yes, it is. Then the last, you do your calculation, and your calculation will give you 4, actually 4 moles of um, Fe2O3. So this is how to use the mole-to-mole ratio. And now, so we'll learn it in this chapter so far. We'll learn how to use, how to get mole from atom, or atom from mole from molecule, molecule from mole from grams, and grams from moles, mole to mole, or mole to molecule to atom. So all of this, we will put them all together and see how we can actually calculate and figure out what to use and what to not use. So we'll put them all together. Okay, solution. This is the one. So this is mass calculation example. Suppose we want, let me see how many examples. So I have 3 examples here. I will do 2 with you, the first one and the last one. So here, suppose we want to determine the mass of NH3 in this equation that can be produced from 32 grams of nitrogen in the following equation. So we will need to organize our thoughts. Let's take this problem to our board here and see how can we do it. here just need, oops, this is so much. Here is our equation. Let's make it smaller. Okay, here you go. So we start with given and needed. So first given, given, and then needed. Given, we have, so first we want the grams of NH3. And then here we have actually 32 grams of nitrogen. And we have the equation. So it's going between the nitrogen. Again, we organize our thoughts gram to grams, but this is between nitrogen and NH3, which means between reactant and the product. Then we need to jump in many steps to reach the grams of the product. So to do this, we need to extract all what we can find to help us figuring it out. So the first thing that we can actually figure out is, and the easiest thing is the molar mass of both the reactant and the product. So molar mass of nitrogen and molar mass of NH3. Okay, so those are from the periodic table. Let me figure out just the numbers from here. I don't want to waste time in doing the calculation. So here it's for the nitrogen, it's a 28.2 grams, and for the NH3 it's 17.04. How did I calculate this? Just by getting the nitrogen and getting from the periodic table plus 3 hydrogen times the atomic mass, and then you add them together here. So this is the first step. The second step is to make a connection between the reactant and the product. To do this, our famous thing that we use, or tool that we use, the mole-to-mole ratio. So here we can say that 1 mole of Na2 can produce 2 moles of NH3, or we can say those are the conversion factors. Now we extracted most of what we will need, so I think it's time to actually set up our equation. So to set up our equation, we will start with 32 grams N2. So now we need to get rid of grams N2. To use this, we can actually try to find grams N2. Here we have grams N2, and here molar mass, which means 1 mole of nitrogen has 9 grams of nitrogen. 1 mole here equal here. So let's cancel these. So here we can use 28.2 grams nitrogen And here we can stay on 1 mole. Oops, hopefully I finished this video. So now we will cancel out our units. Here, gram in 2, grams in 2. Now we ended up having mole nitrogen. Is this what we need? By looking here, no, that's not what we need. So we need to have something that has 1 mole of nitrogen. To look here, 1 mole of nitrogen. You can use this. So to get rid of this, we will be using that one because this is in the top. So times 1 mole of nitrogen, and here 2 mole NH3. And then we cancel out our unit here and here. Now we check, is this what we're looking for? Mole NH3? No, it's a gram NH3. So we still have one more conversion factor to use. We need to get rid of mole NH3. So mole NH3 can be here because we need grams. So we can use this actually. So 1 mole NH3, and on the top we can add 17.04 gram NH3. Oops. Sorry. Okay, now time to cancel out our units, mole and mole. Now we check, is this what we're looking for? Grams NH3? Yes. So we finish up, do our calculations, and then we write the unit grams in each 3. Let's go back to the presentation so we can actually find the right number. And so here is all the numbers, and we will have 39 grams of NH3. Okay, so this is how to actually determine how many grams of the product will be performed when you use this much of one of the reactant. Example number 3 is basically same idea. Now you got the concept. You just go and move between your data to figure out the needed. Okay, so let's paste it here. Okay, move it here. So here it's asking the reaction between the hydrogen and the oxygen produce this amount of water. How many grams of water is reacting? Okay, so again, given and needed. Given, come on. Given, needed. Given is 13.1 gram water. Needed grams oxygen. Again, here you need to think about what are you doing. So you basically have products and need one of the reactant, and you have to figure out how much grams of this. To do this, we need to move in between grams and moles and in between reactants and products. So what we can extract in the given, we can extract 1 mole of oxygen. The molar masses has how many grams of oxygen. We can also how many 1 mole of each